Hello and welcome to Geometry, the Midpoint Formula. In this video, we are going to be using the midpoint formula to find midpoints or missing endpoints, and that's whether it's on a number line or on the coordinate plane using coordinates. If you are looking more at segments and looking at midpoints on segments, then check out my video on the segment addition postulate and congruent segments. In this video, we're going to be using more of the formula. Here are some of the standards that we are going to kind of hit in this video. These are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. So the midpoint is a point which divides a segment into two congruent parts and is equidistant from the endpoints. And equidistant, equi just means equal, and distant is just talking about the distance. So it's an equal distance from those two endpoints. And when we're looking at this particular number line, it tells us that point C is the midpoint of AB. So if we're kind of using a number line, we can kind of figure out the distance here from A to B, and we can see that that's 8. And so we know that our halfway point would be here at -1. But we don't always have a number line, and sometimes it's not as easy to draw a number line, so it's just easier to go ahead and use the formula. So if I was trying to find a midpoint between two test scores, I would take the average. So the midpoint formula is really just taking the average of those 2 points. So I have the midpoint here. X1 is going to be my first point, so that's going to be A. X2 is going to be my second point. When it comes to midpoint, it doesn't matter which one you put as X1 and X2. If you're taking the average of 2 test scores, it doesn't matter if you're taking the average of 70% and a 90% or 90 and 70. So those two are interchangeable for the midpoint formula. Here we've got A, which is X1, and B, which is X2, and we're going to divide that by 2. And so now we're just going to put these two locations. So A is located at -5, B is located at 3, and we're dividing by 2. I like to go ahead and put this entire expression in my calculator. And so we know that if there's more than one thing in the numerator or denominator, we can put parentheses around it. And if you're using your approved calculator for the Florida EOC for Algebra 1 and Geometry, here we are just going to do open parentheses, 5, and then to make it negative, we're going to hit this button down here, plus 3, close parentheses, and then we're going to divide it by 2 equals. And we see that we got that -1 that we were looking at before. And so our midpoint is -1. And that's something that we can clearly see by knowing that our distance between A and B was 8 and then dividing it by 2. And we know that if we're talking about segments, that AC is going to be congruent to segment CB, and that means that C is equidistant or has the same distance from A to as it does from B, which is 4 units from each. Now let's take a look at this particular problem. It says find point C if point B is the midpoint of AC. So now B is our middle point, and if I'm thinking about what it looks like on a number line, I know that the distance here is 3 units, and I would need another 3 units to find point C. So I know point C is going to be at 2. But thinking about using our midpoint formula, here's our midpoint formula again. I know that this is now x1, but point C is going to be x2. So go ahead and make a note that x1 and x2 are your endpoints. So now when I'm looking at this formula here, our midpoint is now B is equal to, and then we've got x1, which is going to be A, plus, and then C is our x2, okay? And so if you want to put C here, you can. And then go ahead and plug in those pieces. So B is at -1 equals A, which is -4, plus point C, or the location of C, which we don't know yet, divided by 2. And then if I am solving, I know that this kind of has these invisible parentheses around it. So I want to get rid of the number that is furthest away from C, or not directly attached to C. So divide by 2, the opposite would be to multiply by 2. And I get -2 is equal to -4 plus the location of C, because these 2's are going to cancel out. And then from here, I'm just going to get C by itself. So now from here, I'm just going to add 4. And I get 2 is the location of C. So here is C right here. And so with these, whether you are using your letters or if you're keeping x2 there, you're just going to treat that just like a variable that you would do in Algebra 1. Now let's kind of switch over into what it looks like for coordinates. So notice that for the formula, it's the same that we've had before, but now we're taking the average of the x's, and then we're taking the average of the y's. So it's the same formula. We're just doing 2 separate pieces. And so we've got the average of the x's and the average of the y's. Same process. So let's kind of label these points already. So we've got P at -4, -3. And then we've got Q at 4, 2. And so I went ahead and labeled those. And then it says find the midpoint R of PQ. So we know that R is going to be in the middle of these 2 points. So when I'm writing my formula, this just represents the x of the midpoint, and this is the y of the midpoint. So I've got midpoint is equal to, and then we've got x1 plus x2. So remember, it doesn't matter which point we put first. So we're going to put x1, y1, x2, y2, and let's go ahead and put it into our formula. And x1 is going to be -4 plus x2, which is 4, and then we're going to divide by 2. And then y1 is going to be -3 plus y2, which is 2, divided by 2. And then we are just solving these separately. So I'm going to look at this one first. And so you can put parentheses around it just like you did before, and go ahead and type that into your calculator. And we end up getting 0 divided by 2, which is just going to be 0. And then you're going to go ahead and plug in this second one. Don't forget to put those parentheses at the top when you go to put it in your calculator. So I'm going to go ahead and bring my calculator up, clear it out. So I've got open parentheses, 3, make it negative, plus 2, close parentheses, divided by 2 equals. And this turns out to be a nice decimal here, which is negative 0.5. And so I could leave it like this. Or I'm going to hit second and then F to D, which is this bottom left button. And it tells me that we could also write this as negative 1/2, and that's just the fraction bar here. That's how it shows up on these particular calculators. So we could also see this as 0, negative 1/2. And I'm going to go ahead and graph that. So we've got 0 and then negative 1/2. And then if you have a graph, it kind of makes sense. If I'm going from P to this middle point, okay, I'm going up by 2.5 and then over 4, and then up 2.5 over 4. So you can kind of think about how we use slope in Algebra 1, and you can kind of use that to also find your midpoint as well. So it's taking that distance that you would have used to calculate slope, okay? From left to right, we have 8 units, and then we're cutting that in half, and we're at 4. So we've got 8 units here, and then we're going up by 1, 2, 3, 4, and 5. And then cutting that in half, it would be 2.5. And so that might be another way that you can find your midpoint as well if you're struggling with that formula, or if you just want a faster way to do it because you already have a graph ready for you. And thinking about the formula, this now represents the x-coordinate of the midpoint. This represents the y-coordinate of the midpoint, and then you could always change this to point R instead of midpoint here, and that way you can go ahead and label it this way. All right, now let's go ahead and take a look at another problem here. And so thinking about how I used the graph last time, if I'm trying to find point E, which is equidistant from D and F, which means E is the midpoint, I could travel down and over. And if I'm going down 3, halfway would be at 1.5. If I'm going over 1, 2, 3, 4, 5, 6, 7, half of 7 would be 3.5. So 3.5 would put me here. And so I automatically know that my midpoint would land here in the middle. And that makes sense as I'm going down 1.5 and over 3.5, down 1.5, and then over 3.5 again. So that would put me here for my midpoint. But let's go ahead and use the formula. So we've got the midpoint is E, so instead of M, I'm just going to go ahead and put E here. And let's go ahead and put our 2 points. So D is at negative 3, 3, and F is at 4 and 0. Okay, and then let's go ahead and label this x1, y1, and x2, y2. And remember, it doesn't matter which one is x1, y1 and x2, y2 because we're looking for a midpoint. So with this one, we've got x1 is going to be negative 3 plus x2, which is 4, divided by 2. And then we've got 3 plus 0 divided by 2. And then let's go ahead and get these in our calculator. Remember, we're putting these in separately. And so we've got, and I'll put this in the calculator again so we can practice. We've got open parentheses 3 negative plus 4 close parentheses, divided by 2 equals, and we get that 0.5. And then I know that 3 plus 0 divided by 2. Okay, I know that that's going to be 3 divided by 2 here. And we get a nice decimal again at 1.5. And if they wanted me to convert these to fractions, don't forget I can hit second, F to D. That would give me a mixed number. So if they have mixed numbers, this would be 1 and 1/2. And then second, A, B, C, and that will just let me know, hey, this is the reduced way of writing a fraction. So anytime you have fractions, go ahead and throw them in your calculator just to make sure that they can't be reduced, okay? And so this is going to be 1/2 and then 3/2. And so either one of these would be acceptable answers. And we can see that based on what I did here with my graph, that is exactly where I put E, kind of using the slope and thinking about the distance between D and F. Now let's go ahead and take a look at another one. So this says find A if C is now the midpoint. So thinking about what my graph looks like, if this is B and then our midpoint is here, I know A should be somewhere here, right? And these are the ones that give people the most trouble, especially when they're using the formula. With the graph, it's not as difficult, but we know that when you're using a graph, especially if you have points that are labeled with decimals and things like that, it may be a little bit harder to kind of visualize and kind of move the points and kind of see where the other point would be. But you can at least get a general sense of where it would be to kind of estimate and make sure that your answer is reasonable. So B, we're going to go down to over 2. And then we're going to go down to and over 2 again. So A should be here. Okay, and that would place C at the middle. So just like how we would travel and put those points when we're graphing lines back in Algebra 1, we can kind of use that same logic here. But we don't always have a graph and we don't always have nice numbers. So now let's go ahead and use our formula. So remember, our endpoints are always going to be x1, y1. So B is at 2 and 3. We didn't know where A was originally. So even if I don't have a graph, sometimes I like to make a diagram. I've got A and B, and then I know that C is in the middle. And I knew that the location of C was at 0, 1, and B was at 2, 3. And then when I go to label these, I know that my endpoints are going to be x1, y1, x2, y2. But now when I look at my formula, instead I've got my midpoint. So my midpoint here is C. So I'm going to put 0, 1 here on the left. I don't know what x1 is, so I'm going to leave it as x1 plus x2, which is 2, divided by 2. I don't know what y1 is, plus 3 divided by 2. And before, when I was solving, this piece gave me the x-coordinate of my midpoint. So I'm going to go ahead and write that as an equation. 0 equals x1 plus 2 divided by 2. And then I knew that this piece on this side gave me the y-coordinate of my midpoint. So I'm going to write that as a separate equation. So now I have 1 equals y1 plus 3 divided by 2. And now we're just going to work to get x1 and y1 by themselves. So let's start with this one. So here, that same idea that we kind of had before when we were doing midpoint with finding the endpoint with just singular points on the number line. We're going to multiply by 2. 2 times 0 is still just going to be 0 equals x1 plus 2 because these 2's cancel. And now I'm just going to subtract 2 on both sides, and I get negative 2 equals x1. Okay? And then I'm going to do the same thing for this other one. So I'm going to multiply by 2. 2 times 1 gives me 2 equals, my 2's cancel on this side, and I'm left with y1 plus 3. Subtract 3 on both sides, and I get negative 1 equals y1. Now I have my x1 and y1. My x1 was negative 2, and my y1 was negative 1. And we can see that's exactly where we put A on that graph by using the slope, right? And so this is how you would do it using the formula. That way, if you have decimals, if you don't have a graph, you can solve it algebraically. Let's go ahead and try one more of these. So this one says point T, which is at 1/2, 0, is the midpoint of SU. And just by the name alone, I know that S and U are going to be my endpoints. So that's going to be x1, y1, and x2, y2. So I'm going to go ahead and draw a little diagram here. I've got S and U, and then it's telling me that T is the midpoint. You can even mark these with your congruency symbols that we talked about in our other video. And then we've got T at 1/2, 0. We've got S, which is negative 3, 1. And I'm going to just add that to my diagram at the bottom. And our endpoints are going to be x1, y1, and then we've got x2, y2. And let's go ahead and get that into our formula. So we know our midpoint is going to go on the left. So we've got 1/2, 0 is equal to x1, which is negative 3, plus x2, which we don't know yet, so we're just going to leave it as x2 divided by 2. y1, which is 1, plus, and then y2, we don't know yet, divided by 2. And then we know that this part, our average of the x's, is going to give us the x coordinate of our midpoint. So we're going to write that as an equation. We've got 1/2 equals negative 3 plus x2 divided by 2. And then our other equation is going to be the average of those y's, giving me the y coordinate of our midpoint. So we've got 0 equals 1 plus y2 over 2. And then let's go ahead and solve. So I'm going to multiply both sides by 2. For these, whenever you have a fraction like this, go ahead and put parentheses around it. In these particular calculators, you have to actually type the multiplication symbol in between a number and the parentheses. It will not automatically register it as multiplication, where most scientific calculators, especially like your graphing calculators or the TI-30XIIS, I think is what it is, would. And so you're going to do 2 times, and then parentheses 1 divided by 2, close parentheses, and then make sure you hit equals at the end. If not, it's just going to show you what you had in the parentheses. So that's going to be 1 equals -3 plus x2, because those 2's are going to cancel. And then from here, I'm just going to add 3 to both sides. And I get 4 equals x2. And then I'm going to go ahead and put that over here underneath my label for u. And then on this one, we're multiplying by 2 again. 2 times 0 gives me 0 equals 1 plus y2, because those 2's are canceling. And then to get y2 by itself, I'm just going to subtract 1 on both sides, and that gives me -1 equals y2. And then we're going to go ahead and check to see if that makes sense. And so it's telling us that it's going to be 4, -1. That would put u here. And then thinking about the slope, we're going down 1 and then over 3.5, and then down 1 and then over 3.5 again. So that's exactly where we wanted to be for u at 4, -1. And this concludes our video on the midpoint formula, and I hope you found this helpful, and I look forward to seeing you in the next video.